Good day, everyone. Today, we will present to you the chemical reaction involved in food processing and preservation and the benefits and harm of it.
First, let us define what is chemical reaction, cooking, food preservation, and food processing.
Chemical reaction is a process in which one or more substances, the reactants, are converted to one or more different substances, the products. Chemical reactions are useful in cooking and help to improve the taste of food. Cooking and chemistry have quite a bit in common. The starting materials in a chemical reaction are called the reactants. These react with each other to form a completely new substance known as the product. Products have very different properties to the reactants. Cakes are firmer and taste better than the individual reactants. The color is different too. Not all chemical reactions need heat energy to make them happen. When bicarbonate of soda and vinegar are mixed, the chemical reaction produces a gas.
Next, cooking. Cooking is the process of producing safe and edible food by preparing and combining ingredients, and in most cases, applying heat. Cooking is a means of processing food without which many foods would be unfit for human consumption.
Food processing. Food processing is the transformation of raw ingredients by physical or chemical means into food, or of food into other forms. Example of food processing includes preparing space food for consumption under zero gravity. It is easy to keep processed foods for a long time. Canned and frozen foods, fruits and vegetables, foods fortified with nutrients such as fiber, vitamin D, and omega-3 fatty acids.
Food preservation. Food preservation includes preventing the growth of bacteria, fungi, or other microorganisms, as well as retarding the oxidation of fats that cause rancidity, thus promoting longer shelf life and reduced hazard from eating the food.
Here are some preservation process. This includes heating or boiling to destroy microorganisms, oxidation, toxic inhibition, dehydration or drying, osmotic inhibition, freezing, a sort of cold pasteurization which destroys pathogens, and various combination of all these methods.
And these are some very common methods of processing and preserving foods such as drying, smoking, freezing, vacuum pack, salting, sugaring, and baking.
So for our example, we will use a baking a cake. So what are the chemical reactions involved in baking cake? You may not think of chemistry when you are baking a cake, but it is definitely a chemically based process. Whatever type of food you bake, the recipe's basic ingredients are involved in several chemical reactions that tie diverse ingredients together to form the finished dish.
Gluten formation. Most baking is based on the use of flour, the powder form of grains, nuts, and beans. Wheat flour, the most commonly used type of flour in baking, is composed largely of starch and protein, with very high levels of a class of protein known collectively as gluten. When water is added to wheat flour, the gluten forms a heavy, pliable mass. This expands greatly under hot temperatures and sets with the desired airy texture.
Leavening agents. Leavening agents such as baking soda, baking powder, and yeast give baked dough its lightness. Baking soda reacts with acid in the dough to make carbon dioxide, which helps the dough to rise. Baking powder, which is baking soda with an additional salt, releases carbon dioxide twice during the baking process. Once when it hits water and again when it reaches a certain temperature in the oven, heat helps baking powder produce tiny bubbles of carbon dioxide, which make a cake light and fluffy when used a single-celled fungus that feeds onto starch and sugar. If added to dough, it also releases carbon dioxide bubbles, giving the dough a light, delicate texture.
Browning reactions. Sugar does much more than just sweeten a cake. When the baking temperature reaches 300 degrees Fahrenheit, sugar undergoes what's known as a Maillard reaction, a chemical reaction between amino acids, proteins, and reducing sugars. The result is browning, which forms the crust of many baked goods, such as bread. The Maillard reaction is not the same as caramelization, but both work together to create appetizing golden brown surfaces and an array of flavors. Sugar also provides a direct food source for yeast, enhancing the yeast's activity.
Emulsification and binding. Eggs in a cake mixture may fulfill one or more of three functions. Beating egg white is used like baking powder to give the dough a light, fluffy consistency. This is possible because egg white or albumen contains lecithin, a protein that coats the air bubbles created during beating, which stops the cake from sinking during baking. Lecithin also acts as a binder to hold the cake together. When egg is used as a glaze, it also acts as a source of protein for the sugar's Maillard reaction.
Remember, when it comes to heat and baking, there are two types of chemical reaction to consider. One is exothermic, a reaction that produces heat, and the other is endothermic, a reaction that takes heat in. As you bake a cake, you are producing an endothermic chemical reaction that changes gooey butter into a fluffy, delicious cream.
A few things can happen when you bake a cake. Some chemical reactions to keep in mind while doing this tasty experiments are: heat helps baking powder produce tiny bubbles of gas, which makes the cake light and fluffy. Heat causes protein from the egg to change and make the cake firm. Oil keeps the heat from drying out the cake.
One of the most harmful effects of preservatives on food items is their ability to transform into carcinogen agents. Some of the food items consist of nitrosamines, a preservative which has nitrites and nitrates, which mix with the gastric acids and form cancer-causing agents.
Food preservation has the following advantages. Food preservation prevents the food from being spoiled by the action of enzymes and microorganisms. Food preservation increases the safe storage period of foodstuffs. It increases the availability of out-of-season foodstuffs. It increases the availability of various foodstuffs, even at distant and not easily approachable places. In other words, it makes the transportation of the food material easier. Food preservation makes up for the deficiencies in the diet.